So this unit of work that we're going to be looking at now is on equation of straight line graphs. It's the upper limit really of grade B. So if you're doing the intermediate tier, this is going to be something that is really going to push you. If you're doing the higher tier, then you know, there are more complicated things than this that you need to deal with. But really, before you tackle equations of straight line graphs, you need to make sure that your algebra is pretty strong. You're quite happy rearranging and manipulating algebraic expressions, substituting into algebraic expressions, and plotting graphs, x and y coordinates from them. So I'll try and summarize first of all the type of things that we need to know. I'm not going to teach you, and I'm relying on the fact that you will have already done some sort of review and revision before looking at these. So basically, if you have an expression which links y and x, such as that, where the x and the y variables have no powers, then it's going to generate a straight line. And what happens is that this rule will give you a y coordinate for any value of x that you put in. So if you want to plot that, what you would do is substitute in some values of x and work out the corresponding values of y. So let's say, for example, if x is 1, y will be 7, and you're going to replace the x with a 1. And in algebra we have to put a multiply in then. Take away 2. 7 times 1 is 7, take away 2 is 5. So that gives you a coordinate, x coordinate 1, corresponding y coordinate 5. If you put x as 2 in, then you'd get 14 take away 2, which is 12. So if x is 2, y is 12. If you put x as 0 in, then basically it eliminates this part of the expression, because anything times 0 is 0, giving you negative 2. And that's an important characteristic. If you put x as 0 in, it always gives you this value, and that value is known as the intercept on the y-axis. It's where the line is going to cross the y-axis. So we got 3 points there now, so we could plot that if we wished. Let's do a really crude little sketch. Y, x, if I'm going up 1, 2, 3, there's 0. And if I go up, I'm going up to 12, 2, 4, 6, 8, 10, 12. It's going to cross 1, 2, 3. So we're going to have the coordinate 0, negative 2, 1, 5, and 2, 12. So you can see it's a really bad diagram, but that would then produce a straight line where it's crossing at negative 2. If I was to change that number to a 4, then these y coordinates would become smaller because I'd be multiplying by 4. The effect of that would be that that slope would become less steep. So the smaller that number, the less steep your line. The steepness of the line is called the gradient. The larger the number, the more steep the line. This leads us to the general form of that, which is known in maths as y equals mx plus c. The c is what y becomes if x is 0, so where it crosses the y-axis. So the c is known as the intercept on y-axis, and this is known as the gradient. If you've got an uphill slope like that, the gradient will be positive. So uphill If you're travelling from left to right, positive gradient, so positive m. If you have a downhill slope, then the gradient is negative, so you have a negative m. So this is the format that we'll be talking about when we're looking at the questions. Now, the format isn't always given y equals something something. If this side has a fraction in it, you may end up with an equation like that. And what you need to do in order to make sense of it if you're comparing lines is to get the y on its own by dividing everything by 3. So if we divide everything by 3 there, we'd get that over 3, and we'd get that over 3. Well, 6 over 3 is 2. So in the form y equals mx plus c, we've got that. So we've got a gradient of 4/3, and it's going to cross the y-axis there at 2. So sometimes we'll need to do a little bit of rearranging like that. Sometimes you'll need to calculate what the gradient is. So if I come up with a sort of bad example here, let's say that's my line, and let's say I know that that point is minus 4, 8, and I need to know another point on the line in order to work out the gradient. So if I know that this point here is, let's say it's 2 minus 2, in order to work out the gradient, you need to work out, if that was a right angle triangle, what that distance is going to be. Well, this distance, you're going from 8, that's 8, and that's 2, because you're going from 0 to 8 that direction. You're going from 0 to negative 2 in that direction, so that total distance is 10. And you need this distance, which is going to be 4 from there to there, and another 2, so that distance is 6. To work out the gradient, it's the difference in y, so it's your vertical difference in y coordinates over your difference in x coordinates. So in this case, that's 10 over 6. So that's the gradient, apart from, because we've got a downhill slope here, I know that that gradient is negative, and I can simplify that because both of those divide by 2. So that simplifies to minus 5/3. So if I wanted to work out the equation of that line, I know that the gradient part is minus 5/3. Now, if that had gone through the origin, if it had crossed 0, 0, that would be the rule. If, let's say, that is actually 1, then that would be cutting the y-axis at 1, which would be the plus c bit at the end. So that equation would be y equals minus 5/3 x plus 1. So we can calculate a gradient from a line, so long as we know some coordinates on it, by working out the distance, the change in the y coordinates, and the change in the x coordinates. Positive if it's going in the direction of my pen, uphill. Negative if it's going in the direction of my pen, downhill. We can plot an equation of a line by substituting in coordinate values, and we can rearrange an equation of a line in order to excuse me, get it in the form y equals mx plus c. The other thing that we need to be able to recognize is what happens with parallel and perpendicular lines. Well, if lines are parallel, if you imagine that line there is parallel. What doesn't change is the slope. The slope, this gradient, is the same. Steepness is the same. So a line that's parallel to that one will be one that has the same gradient. So y equals 4x over 3 minus 10 will be parallel. Plus 10 will be parallel. So long as this part doesn't change, the gradient doesn't change. So parallel lines, same gradient. Perpendicular lines, so a perpendicular line, which will be one that is at right angles to the other one. So with perpendicular lines, there's a different relationship. The relationship is that the gradient of each of them, if you multiply them together, produces -1. But the quickest, easiest way to think of that is if I want to find the gradient of a line that's perpendicular to this one, I take that, I change its sign, and I turn it upside down. So the line that's perpendicular to this one will have that gradient. The line that's perpendicular to that one will be minus, and if I turn that upside down, it's actually over 1, but we never have to write that in, so it'll be minus 1 over 7. The gradient of this one will be plus 3 over 5. So you can't see that. So for parallel, any line parallel to that one will have the gradient minus 5/3. Any line that's perpendicular to it will have the gradient plus 3/5. Any line parallel to that will have the gradient 4/3. Any line perpendicular to it will have the gradient minus 3/4. Any line parallel to that will have the gradient 7. Any line perpendicular to it will have the gradient minus 1 over 7. So there's quite a lot to remember with this, and as I said, if you're wobbly with your algebra, then I really wouldn't bother going through this until your algebra is well practiced and you're confident with it. Okay, so that's the sort of background that hopefully I'm just refreshing with that, and you know, it's been reinforced by your teacher and by your revision beforehand. So let's take a look at the questions. Get the mark scheme ready so I can tell you how the marking happens. Okay, zoom in a little bit. Now we're off and running. Two different straight lines have the equations y equals 4x plus 3 and 2y minus 4x equals 10. Are these lines parallel? Well, that's already in the form y equals mx plus c, so you can see straight away that this line has a gradient of 4. So the question is, does that one have a gradient of 4? So we need to rearrange that into the form y equals mx plus c. So let's keep the 2y there and deal with this. In order to get rid of that, I need to add 8x to both sides. So if I add 8x to this side, I get it in the form 10 plus 8x, but you see, I'd rather write it as 8x plus 10 to get it in that mx plus c form. Now to get the y on its own, I'm going to divide everything by 2. So y equals 4x plus 5. So this has got a gradient of 4. So yes, they are parallel. They both have the same gradient. So we can see straight away what the gradient of that one is. It's 4. What do I need to do to get the gradient of this one? Rearrange it, divide by 2, it's 4, and then to nail the answer home, yes, they both have the same gradient. So 1 mark for getting them both in the same form, and 1 mark for concluding that they are parallel. Use the graph paper below to draw the graph of 3x plus 2y equals 12. So we could rearrange that straight away, because part B I need to work out what the gradient is, or I can just substitute values in. It really doesn't matter which way you choose to go about doing that. Let's just choose values of x and work out the corresponding values of y. So always easiest to start with when x equals 0, because that gives us the intercept. So 3 times 0 is 0, so we just get 2y equals 12. Why have I written 16? 2y equals 12, so 1y is 6. So when x is 0, y is 6. Then let's choose x as 1. 3 times 1 plus 2y equals 12. 3 plus 2y is 12. Take 3 off each side. 12 take away 3 is 9. Y is 9 over 2, 4.5. 1, 4.5. You only need 2 points in order to draw a straight line, but it's always worth plotting a third to make sure that they lie in that straight line. Otherwise, you may find you've gone wrong. So let's do 2. So 3 times 2 is 6, plus 2y is 12. Take 6 off both sides, divide by 2. So x is 2, y is 3. So on my graph, x is 0, y is 6, 1, 4.5, 2, 3. That looks good. That looks a pretty straight line to me. So I'm quite happy that that is going to be right. Right, on the gradient, so now I need to rearrange that into the form y equals mx plus c. I want the y's on their own on the left hand side, so I'm going to take that 3x off, have to do it to both sides. So 12 take 3x, I'm going to write like that, just so it's in the right place. Then I'm going to divide everything by 2. That's my gradient. So the gradient is minus 3 over 2. You could have done that by calculating it, by working out the change in x coordinates and change in y coordinates and x coordinates off the graph. So that's the other thing with equations of a line. Lots of times there's more than one way of answering the question. But again, I'm happy with that because that's a downhill slope, so I know it should be negative. Marks for that. Up here, there's 2 marks for plotting 2 correct points, and 1 mark for drawing the line through the points, and the 1 mark for this is for the minus 3 over 2. Part B. Select from the following list of equations to complete the table below. Passes through the origin 0, 0, parallel to 3x, intersects the y-axis at 5. So if it passes through the origin 0, 0, it hasn't got a plus c part to it. I think what we'll do is, if we rearrange each of these into the form y equals mx plus c, so the first one, we're going to take plus 4x off each side, so we get that. B is already in that form, but because there's no number there, if we write that as plus 0, that is telling us it's passing through the origin, it's crossing the y-axis at 0. So that first one there is B. C is already in the form y equals mx plus c, and that's going to cross the y-axis at 7. That's going to cross the y-axis at 3. D, if we rearrange that, we have to add 3x to both sides, which means that has a gradient of 3, that has a gradient of 3, so those are going to be parallel. So that one is line D. This one, if I rearrange it, to get y equals, I need to take x off both sides and add 5 to both sides, meaning I end up with negative x on that side plus 5. That's going to cross the y-axis at 5, which is that one. And then, just to rearrange this for practice, although I've finished the question, I have to divide everything by 2. So I get 3 over 2 is the gradient, and 5 over 2 is where it's going to cross the axis. So there's 3 marks for that, 3 right answers. Two of the equations below represent straight lines that are perpendicular to each other. Select the 2 equations that represent the lines that are perpendicular to each other. You must show by calculation that the equations represent perpendicular lines. So what we need to do is to rearrange those into y equals mx plus c and go from there. So the first one, so if I call that A, B, C, D, E, F. Equation A, I have to divide by 4. So y equals x over 4, which is the same as a quarter x. So the perpendicular gradient to that will be, change the sign, negative, turn it upside down, 4. So I'm looking to see, is there another line which has got a gradient of negative 4. For line B, that is y equals 3 quarters x. I have to divide by 4. So the perpendicular gradient for that one would be, change the sign, turn it upside down, negative 4/3. Equation C, I'm going to divide by 3. Perpendicular gradient would be, change the sign, negative, turn it upside down, 3. Line D is just got a gradient of 1. So the perpendicular gradient would be negative 1. Line E, I'm going to divide by negative 4. Which gives me that. Which has got a perpendicular gradient of plus 4. And finally for f, if y equals y equals negative 4x, that perpendicular gradient is plus 1 over 4. So two of the equations below represent straight lines that are perpendicular to each other. So for this first one, I'm looking for a gradient of negative 4. None of them have got a gradient of negative 4. For this one, I'm looking for a gradient of negative 4/3. None of them have got a gradient of negative 4/3. This one, negative 3. Nothing's got a gradient of negative 3. Negative 1, nothing. Plus 4. Nothing's got a gradient of plus 4. But this one, f, has got a gradient of negative 4, which will be perpendicular to a. I'm looking for a gradient of negative 4. This line has got a gradient of negative 4. So the two that are perpendicular to each other are line A y equals, or 4y equals x, and this one, sorry, I lost it, is line F, which is y equals minus 4x. Those are your perpendiculars. Sorry, I got confused then. Why I paused was I wasn't sure whether there were two pairs or two lines. There are two lines, so there's only one matching there. So the marks for that, there's one mark for correctly selecting the right lines, and one mark for showing that one is the negative upside down of the other. If you remember when I said that it means that when you multiply them together you get negative 1, so what you've got is negative 4 times plus a quarter, that's an times, not an x, so minus times a plus is a minus, 4 lots of a quarter is 1. So when you multiply the two gradients together you get negative 1. Question 4. Which of the two lines are parallel? Give a clear reason for your answer. So we're looking for the two lines with the same gradient. That's got a gradient of 3, negative 3, negative 2. That's got a gradient of 3. So it's A and D, because they both have the same gradient, and that gradient is 3. Which of the two above lines intersect each other on the y-axis? So now you're looking for which of the plus c's are the same. So that crosses at 4, at 3, at negative 4, at negative 5, at 4. So it's A and E. And that time you don't have to say y, you just have to correctly get the right two. So it's A and E because that's plus 4, that's plus 4. Question 5. Select two of the following lines which are perpendicular to the straight line AB shown on the grid. You must write a reason for your selections. So the first thing we need to work out is what the gradient of that line is. So this is what I was saying about you draw your right angle triangle and you pick your points so that you can read off the coordinates. So I'm not going to pick a point there, for example, or even there, because it's somewhere between two. So I'm looking for where the line crosses the cross points on the graph paper. So I'm going to choose that point there, which is the point 2, 9. And I'm going to choose, well, I could choose that point there, which is 4, 6. Or I could have gone to point B and even used A and B. It doesn't matter. So I need this distance, which is 1, 2, 3. And I need this distance, which is 2. So the gradient is y difference over x difference, 3 over 2, and it's a downhill line, so it's a negative gradient. So the gradient is minus 3 over 2, which means I'm looking for a gradient up there which is perpendicular to that, so it's going to be plus 2 over 3. Well, it's not that one, because that's 3 over 2, so I can knock that one out. It's not that one, because that's minus 2 over 3, it's going to be negative. That one, hang on, where am I going from there? What can I eliminate next? So this one is going to be negative 2x when I take that over. So 3y equals minus 2x plus 8. So it's not that one because I'm looking for a positive value. That one is already positive, but I'm going to divide by 2. So it's 3 over 2, not 2 over 3. So it's one of these two. This one is y equals, I have to divide everything by 3. So that's going to have a gradient of plus 2 over 3. And this one won't, because when I take that over, it becomes negative 2x. But when I divide, I'm dividing by 3. Sorry, so this one is, select 2 of the following lines. I'm now going to divide by negative 3. And negative divided by negative is a plus. So that's equal to plus 2/3 x. So that one and that one both give the right gradient. So it's 3y equals 2x plus 5 is 1, and 2x minus 3y equals 8 is also 1. So if I just quickly talk you through that again. First of all, you need the gradient of that line. So you choose a pair of coordinates on there that you can read off. Work out the change difference in the y coordinates. Work out the difference in the x coordinates. The gradient is the difference in y over difference in x, 3 over 2. But because it's downhill slope, it's negative 3 over 2. So if that's the gradient of that line, the perpendicular line would be change the sign, turn it upside down, plus 2/3. You've then got to look at these and rearrange them to see which of these lines have the gradients plus 2/3. Question 6. A straight line graph is to be drawn using the following information. It is perpendicular to the line with equation 2y plus 4x equals plus 3, and it intersects the line x plus 3y equals 12 at the point where x equals 0. Write down the equation of the straight line that's to be drawn and then draw it. So from this line, I divide throughout by 2, 4 over 2 is 2. It's going to be perpendicular to this, so gradient of our line will be minus, change the sign, 1 over 2. For this second line, it intersects x plus 3y equals 12. Well, that crosses the y-axis when x is 0. The x-coordinate is 0 on the y-axis. You get 3y equals 12 divided by 3, y equals 4. So the intercept of our line is plus 4. So the equation of our line is going to be m minus a half x plus c plus 4. So then they want us to draw that. We know it's going to cross the y-axis at 4, so I just need another pair of coordinates. So if I choose x is 1, we're going to have y equals minus a half plus 4, which is minus 3.5. No, it isn't. It's plus 3.5. Minus a half plus 4 is 3.5. So I've got the coordinate 0, 4, and I got the coordinate 1, 3.5, and let's get one more just to be sure. X equals 2, y is going to be minus a half times 2 plus 4. Well, 2 halves is 1, so that's going to be 4 minus 1, 3. So I've got the 0.23 as well. Okay, so to draw that, one, two, three, 4, 0, 1, 2, 3, x, 0, 4, 1, 3.5, 2, 3. So there's my graph. Y equals minus a half x plus 4. So how are the marks awarded for that question? There's 2 marks for establishing that you're looking for a gradient of minus a half. There's 1 mark for the intercept of 4. There's 1 mark for actually combining those into the right equation. So 4 of the 6 marks is for getting the equation, and then there's 1 mark for making your graph fit the graph paper, and there's 1 mark for correctly drawing the graph. So as I've said, intermediate tier, this is pushing upper limits of grade B. Higher tier, this is in the first half of the paper, you should be able to cope with that. Question 7. Find the equation of the straight line shown in the following diagram. Write your answer in the form y equals mx plus c. Well, the plus c is 6, it's where it crosses the y-axis. So c is 6. The gradient, I want a triangle. So if I take that point there and this point here, that distance is 6, this distance is 2, and it's an uphill slope, so it's positive. Change in y, difference in y over difference in x is plus 3. So the equation of the line is y equals 3x plus 6. On the grid above, draw the straight line which has a gradient of -2, which passes through the point 0, -1. So gradient 0, -1 is where it's going to be crossing the y-axis. So I can write that straight down as an equation like that. I know it's crossing at -1, which is there, so I only need one more point, but I'll generate 2. So if we put x as 1 in there, I get y equals -2 times 1 is -2, take off another 1, -3. So x equals 1, y equals -3. 1, -3. So if I put 2 in there, y will be -2 times 2 is -4. Take off another 1, -5. 2, -5. They lay in a straight line, so I'm happy that I haven't made a mistake. There's the line. Sorry, I haven't shown you where the marks are awarded for that one. So with this, straightforward, 1 mark for the 3, 1 mark for the 6. And for part B, one mark if you draw the line with the correct gradient, both marks if it's crossing through the right place as well. Finally, question 8. Straight line shown in the sketch above intersects with another straight line which is not shown. The other straight line is perpendicular to the straight line shown. The two straight lines intersect at the point where x equals 1. Find the equation of this other straight line. So with this, I can find the gradient of the given line. I know that that distance is 9, that distance is 3, and it's a downhill line, so it's negative. So that gradient is going to be negative difference in y's over difference in x's, -3. So the line that I'm trying to find is perpendicular to it, so that will have a gradient which is plus, turn that upside down, 1/3. So my equation, y equals mx plus c, I can now write as y equals 1/3 x plus c. The two lines intersect at the point where x equals 1. So the equation of this line, I now know the equation of this line is y equals -3x plus 9, because I know it crosses the y-axis at 9. So when x equals 1, I can work out what the y coordinate is from this line. And that will tell me where these cross. So when x equals 1, y equals -3 times 1 is -3, plus 9 equals 6. So the lines cross at 1, 6. Make sure you're happy with that. I can work out the gradient of the given line. The gradient of the given line is downhill, so it's negative. Change in y 9 over change in x 3. Gradient is negative 3. I can then just write down the equation of this line because I can see what the intercept is, what the c part is. So that's minus 3x plus 9. The question is then saying that the line that I don't know anything about crosses at the point where x equals 1. Well, I can put x as 1 into this equation and work out what the corresponding y coordinate is. So I know these two lines are crossing at this point. I also know that this gradient is perpendicular to that gradient, so it's going to have a gradient of plus 1 over 3. So all that I have to do to finish this is to substitute these values of x of y into my new equation to work out what c is. So y is 6 times 1 plus c. So um, 6 equals 1/3 plus c. To get the c on its own, I'm going to take a third off each side. If I take a third off that, I get 5 2/3 equals c. You tend to write that as a top-heavy fraction, which will be 15 17/3. Which you would then look and think, oh my god, I've gone wrong somewhere. So the equation of the line y equals 1/3 x plus 17/3. Now it's not asking you to give it in any form, so you can leave it like that and there's nothing at all wrong with that. Or you could, to get rid of the fraction, multiply throughout by 3 and write it like that. If you're doing higher tier and you're thinking of going on to A level, you'll do an awful lot more work on equations of lines and work like that. But higher intermediate tier, if you can follow that, and if you can do that yourself, you probably are doing the wrong tier, to be honest with you. That is very much, like I said, pushing high grade B. So there you go, that is equation of a line. Pretty challenging stuff.